Okay. I think everything's working. Okie dokie. What's that doing? Okie dokie. Those brackets still. Just messing with the appearance right now. I just moved all these components to the playfield assembly. And it decided to assign the material settings of the playfield. Going back and just messing with this. Not really necessary. But easier to differentiate parts. Make my coils yellow. Why not? And I'll give those a rubber color. Doesn't matter. Alright, they're starting to look a little bit more like actual components and not wood. Just so long as you can kind of differentiate here they look, but like those rings definitely should not be that. Getting better. Close enough. Targets all look fine. That switch should not be wood. Alright, better. I'm not gonna mess too much worrying about bushings in the sleeves and stuff like that. Worry about those guys. Okay. Said I'm not gonna mess with it, but I'm messing with it. Oh no, I just want it to look normal-ish. Close enough. Like I know those plates should not be wood. Those should be a little bit of that guy. I had copper in here too. It's a pain. So I already did this for all this stuff once before. But apparently moving it to a new assembly just disregards everything I did. Most of the mechs are prefab. Some of them I altered. So, like some of these, the switches, I think it was like the narrow targets weren't prefab, but I just took some of the other ones with the mounting bracket that I want, whether front or back, and I chopped them down into their own new component. What else did I messed with? So there wasn't a prefab single drop target. So back in there is a single drop. Ugh. So I took a 3-bank drop and turned it into a single. I think that's about all that I've modified, really. But yeah, mostly prefab. And what I'm trying to do is I'm trying to make sure everything fits mechanically before I go to cutting my first whitewood. Because I have like kind of a lot of different stuff that I want to do with this. So I want to make sure that it'll all work before I cut a whitewood. Playfield itself is from scratch. Like there's kind of pre-made files out there for the playfields with different lower third setups, but the lower third I'm doing is kind of unique. Yeah. Alright, looks a little bit more normal. Yeah, so I actually designed this in Visual Pinball first. Just to get general flow and shots and how I want things to work. From what I've heard, it's a pretty good transfer to a physical machine. I know Ryan McQuaid did that with Sonic. So I'm excited to get to the point where I can actually have a physical whitewood. But yeah, I'll fire up the table here just to show you. There's some diverters and stuff that's not in the CAD file, not yet. And kind of like the little upper play field in the middle that looks translucent white is actually going to be acrylic, and that's going to be underneath a 3D print of Hogwarts. So back in the back right corner is a sorting hat diverter. It's what is there? 1, 2, 3 ways in. No, 4 ways in. There's a VUC hidden behind it too. And 5, 6, 7 ways out. And the diverter can change the path of any of those entrances. That'll be pretty cool. I was kind of stuck back there for a minute. What else do we got? So on the lower right side is Hagrid's hut, and that'll have a bank of 4 targets that kind of rotates out. So it'll either block that outer orbit, or it'll be a open shot for the outer orbit. There's also, so when the target bank is closed, there's an under the flipper shot into a subway entrance that's inside of the hut. Yeah, you know, so this is my very first one. And, I mean, so far the process has worked pretty well for me. I've had like 50 different iterations of this in Visual Pinball first, just to get an idea of what kind of flow I want, and you know, where do I want some of the like primary points of interest to be, features as far as like the castle and Hagrid's hut and sorting hat, the Quidditch pitch, all that stuff. The Flu network, like like that shot there is a flue network. And same goes if you go to the outer flue network shot. It'll kind of pop up anywhere. So my goal is to have instantaneous subways. So when it goes in one place based on code, it'll pop out another like instantly. Which means there's going to be a whole lot of ball staging underneath the playfield. And I've got a subway sketched up on paper at least for how that'll work. So that should be pretty cool. Trying to do like a lot of semi-unique things. In the center, that shot there is a captive ball. That is like the Horcrux shot. So, and I had it coded once upon a time. I don't know if it still works. At least in Visual Pinball, where if you hit that captive ball 3 times, it'll release into a multi-ball. Lots of magnets. Lots and lots of magnets. Some steppers. That shot's cool there. I like that shot. Probably going to be a little bit difficult to dial it in a physical table, but... yeah. So, if you have any, like, questions as far as, you know, what I'm planning or what certain shots are gonna do, feel free to ask. My thought process going into this is I want just about every single shot to have multiple outcomes based on the mode state of the game. So there's lots of diverters, lots of magnets, all that kind of stuff. So like, for instance, if I shoot the far left orbit where the spinner is, it can either go up that ramp to the sorting hat diverter, or it can go all the way around to the outer right orbit exit. Same thing if you shoot the outer right orbit. It can either go, not that one, it can either go all the way around and back out the left side, or a magnet can grab it and drop it into the subway. The inner orbits, so like that right spinner there, will either loop all the way around and back down the right side to feed the right flipper, or it will go all the way around to the left outer orbit based on diverter. That left inner orbit that I just shot there, just left of the captive ball, will either come all the way around to the right flipper, or a magnet can grab it and drop it into the subway. I've thought about having a magnet grab it and drop it into the pop bumper area, but I kind of want the pop bumper area to be more of an intentional shot. Not just something that randomly drops it up in there. Because there's no in lanes like you'd see in a normal pop area. Yeah. That's about it for the visual pinball side of it. I can always pop this back up later if there are questions. The upper playfields are by no means set in stone, they're just kind of placeholders. Shot layout and size and everything up there is all probably going to change. Yeah. Back to Can. So as far as like all of the guide rails and stuff, I kind of right now just have it carved into the white wood so that when I'm trying to bend metal and get it right, I can use those as little references. But also so I can use like paperboard and stick it in that slot to give me like temporary guide rails until I can do the metal aspect of it. But eventually those will be sheet metal. What do I want to work on? I think I'm going to try to figure out this left diverter. I'm going to put in my side rails first. Draw those, sketch those. I'm trying to remember what size the pinball life ones are. Right there. 1 1/8 inch by half. Let's do this inside of the play field. Create a sketch on that plane. Okay. So there's the profile of my rail, and I'm gonna extrude that all the way to the back edge. So up to this point, a lot of the work has been just hole placement and figuring out how, you know, targets are going to fit next to posts and making sure all the mechanical stuff fits. So now I'm kind of looking to start, so you can see like on the underside I've got all the holes for the T-nuts and everything that I need from that standpoint. Most of the mechanical stuff is here for, at least for starters. I don't have any VUCs in here, just because there's not a pre-made model. But I've been kind of thinking about sketching one up, just so I have one. But yeah, target placement, drop targets, flippers, all the bigger mechs, those are all kind of in place. Making sure I have pathways for the subway in between mechs. So it's kind of been all that up to this point. A lot of time spent on the lower third and lane width and kind of preemptively positioning holes so I can move posts around if I need to loosen or tighten up some of the lanes. Also, my bulk trough area, the apron area, is a little unique because it's one of the features that I'm going to try to do. So there's going to be like a magnet in this hole here and a magnet in this hole here, and it'll be like the Dobie ball save. So when it's lit and you're in single ball play, it would use this magnet to fling it along the guide rail and up to this other magnet, which would fling it up the rail and out of an in lane, out of an out lane, back into play. So there's been a lot of like making sure the guide rail and the what should be the path of the ball travel doesn't like hit a post or anything funky, so it should get a clean exit. And then there's going to be a lot of code to get that to work, and probably a lot of fine-tuning and adjustment. But yeah. New component. So there's that side rail. And it should be listed down here, component 108. Side rail. And I'm just gonna copy that point to point. There we go. It's like the easiest thing I've had to draw. Wonder if I can give those like a black vinyl wrap look. There. Looks a little better. The other thing I need to figure out is, so I've kind of got these just play fields mocked up and floating here. I have them kind of sketched so I can do like a post back here to support it, and a post here, and one here, and then one back here. So that would have like 4 posts to support it. So I need to put in post holes for that and plan that accordingly. Make sure there's still space under here for that. One's probably going to be buried under, yep, be buried under that flipper plate. The other one should be accessible. Here. Should be doable. And then I probably need to sketch some of those post components, because not all of those exist that I want to use. Yeah, like any of the hex posts or anything for supporting upper playfields don't really exist in here. I'll probably have to build those. Okay. That was bugging me. Slide plates should not be wood. Yeah. So I think what I want to work on is trying to figure out this diverter here. So you can see there's 2 shooter lanes. Each of them are going to have a diverter that lifts up out of the way when you shoot. Like on the right side, it's this little guide rail here that would lift up out of the way. And on the right side, it's going to be this guy. And I'm kind of thinking for that, I might be able to engineer a two-way. So like this back portion back here needs to be out of the way during normal play, but it needs to be there when you shoot the ball. Because I have this flue network discharge a ball that would come and zip into your left flipper. So this needs to be out of the way for that, but whenever you shoot, the bottom one needs to be out of the way and this one needs to be down. So on one of these sketch pads, kind of drew up the concept. It kind of looked like that, and then it would use a coil underneath to pull a lever that would articulate the upper portion down and lift up the back portion over a pivot point. I need to draw something like that. So I think I'm going to do a new sketch on the playfield surface. And I'm going to project some of the geometry. Okay, done projecting that geometry, so now offset of it. I'm gonna have to do these. Oh, see, now it lets me do it. Or it wanted me to select the whole geometry all the way around. Okay. Okay. I drew a line there, maybe not. There we go. So I need to do the curve, the inside curve there. And I'm thinking what I need to do to sketch this. Do two different extrusions and then figure out where to pivot and all that junk. There. Used to be like 1 inch tall-ish. Right? I'll do the same thing with the other one. Hard part here is I gotta have... So this needs to be low enough to catch the edge of the ball as it's going by. And provide a good, clean guide. But then when it's raised up, it needs to be out of the way enough. Hide that sketch on me? I think it did. Every time you do an extrusion in this, it's just gonna hide a sketch. Which, it's not there. Where did I put that? Sketch 13. Oh. Gotcha. Offset extrusion, 1 inch. And we'll just make it 1 inch. Why not? So I need to figure out where the pivot point would be. Just try the center of this thing here. Okay, and rotate, and I select that as an axis. Yeah, okay. So 15-degree angle. Get that up out of the way. First thing, before I do this, like take the bottom edge, like the bottom face of that. And like, what's the lowest that I need, weight-wise, for that edge of the ball to hit it there. Ball is about 1 inch. Needs to be about 1/2 inch for the center. Call it 3/8. That way there's a little bit of wiggle room. Okay, so now, when that rotates up out of the way, I need that to rotate up enough to give me clearance for the ball to come through. Do another sketch. And say that's 1 inch ball. 1 1/8. To give a little bit of clearance. And that. And that. So that'd be the ball kind of rolling through there. Let's try to rotate that component now. Go back to 15. Take a look from the front. I feel like it's going to take more than 15. 25. Okay. Getting close. 20. He's cutting it really close there. But if I make that ball size 1 inch, there's a lot of clearance there. I mean, it depends on how much it's like jumping around, I guess. I mean, it could work like that. I feel like that would be sufficient. Set at 20. And change that ball size back up to 1 1/8. So now I need to go back to the sketch here and extrude the other portion up. That needs to come up an inch. New body. That and that. What did I do? 3/8 on the other guide. 3/8 the same here. Sorry, getting caught up in the music. Okay, there's that. So I need to do another join extrusion with an inch offset, and I did it an inch high. Body. And now I want those two to join. Okay. So there's that body there, that body there. So now, let's rotate this one. And make sure that it can, at 20 degrees, also be up enough for a ball to go through. There's -20. Not enough on that one. Might be 25 is the angle we gotta use. 22.5. Oh, that could be alright. Considering it's gonna be sitting a little bit lower coming out of the shooter lane. Gonna be a little bit more centered. 22.5. Okay. Set this back to 0. Other body. That again. That needs to be sure. If I do -20 on that, it should be flat. Yep. Let's do 2.5 degrees up. That'll get me 22.5. That's about the shape of that diverter. Might look a little funky, but I'll find a way to disguise it. So this way, when a ball is coming out of this vuck down towards your left flipper, it clears the raised up portion there, and then feeds down across the out lane to your left flipper. And then when a ball is shooting out of the left shooter lane, this will pivot to pull this upper portion down, which will lift up the back end here, and then the ball will clear underneath that, and we'll have a guide here to allow you to skill shot out into the playfield, over towards these targets here. It can also, full blast should go up through the spinner loop, either the left or the right flipper, and then the little secret thing will be a magnet on a linear bearing, so it'll grab the ball anywhere between here and here. It can move it back and forth. I'm gonna hopefully be able to fling it like up into this orbit. I'll definitely be able to fling it straight up, just pulsing the magnet, but I think if I pulse the magnet while that it's traveling on the linear bearing, I should be able to, in theory, fling it in a direction. Okay, so that works there. So I guess now let me clean some of this up. I don't need to see that sketch right now. To find the bodies. Let's edit this sketch. Playfield. What I'm doing here is kind of using circles to trim down, just say at 2.75. Trim down the diverter so it can actually pivot without hitting the... Oh, thank you. Glad you enjoy my post collection. Okay. Let's go back to edit that sketch. I don't want that to cut stuff out of raised portion there. Where's that sketch? Right there. The CNC is set up. I haven't carved too much on it yet, because I've been procrastinating at getting the whitewood to a point where I'm ready to cut it. But I did do some planing of the waste board to get that all level, so that's ready to go. I want to get out there and like create some good kind of guides so I can just back a piece of plywood in there to set 0 without too much hassle. It'll pretty much already be squared and ready to go. I'll probably do that before I cut the whitewood, I think. So I'm gonna draw that line there, and delete its thingies, constraints, and then let's rotate it around the same axis and rotate it 22.5 degrees. Oh no, that's not how I want to do it. Oh wait. I don't know why there should be no constraints on that there. Okay, there's that one. Let's try to rotate this again. There we go. 22.5 degrees. I'll give me that there. From those. Alright. Now I should be able to use that to cut away from that. Yeah, I'm actually very happy with it. I had a Bosch, like a really good Bosch router that I'm using with it. I need to get a collection of bits, actually. I've got, you know, some ones that came from Amazon, but I guess I really need to figure out what bits I'm gonna need for doing the whitewood, and then make sure I have them, and get lots of them in case I break any. Yeah. You have a CNC, Borg Dog? I know you either had one or you were talking about getting one. Ah, okay. Yeah, I've seen the One Infinity ones too. Not sure how good they are or not. I don't have experience with them, but I gotta imagine they're pretty decent too. I think the One Infinity ones have like the tube rails, if I'm not mistaken. I don't know what it uses for, like a drive system on those, if it's belt or it's linear bearings. But from the research that I had done, the linear bearings are the way to go. Because the problem with the belts is they get loose and stretched out, or they slip. Okay, gotcha. Yeah, that should be good. Yeah, I do. So like the CNC for newbie one, I got like a big footprint. It's like 54 by 54 inch. I forget what the actual model is, but I can do a whole 4 foot by 4 foot piece of plywood in there without issue. And that's what I wanted, so that I could do like a whole play field without having to shift things around. So that's why I went with the size I did. Yeah, but I like it so far. It was a worthwhile investment. I need to actually start like a business doing some other fun stuff with it. So right now it's just kind of sitting, waiting for me to do the play field, but I need to find a way to like pay it off with itself. So I need... How far down is that? I need a circle right about there. There, or an arc from there to there. Do a new sketch. And... 3-point arc. There. Something like that. Actually, that's probably about what I want. I just don't want it going outside the edge here. Oh, I guess that'll do it. Tangent. Feet, not too big. Can do play fields. The largest 150 is 30 by 50. I mean, that's a good size cutting area. I mean, that'll cover you for most things if you're doing play fields or like getting creative with some signage stuff. I would like to do some kind of like 3D recessed carvings, like scene carvings. Another idea I had too is to try to tap into the pinball market a little bit. So I was gonna see if I could find a way to do like take a overhead picture of playfields and then do a 3D recessed carving of a playfield and turn it into art that was, you know, about the size of a piece of paper. I think that could be cool. Signage, flippers, stuff like that. Things that you can like put a logo on, or yeah. I was thinking about doing like an Etsy shop or something. Right now I'm just kind of messing around with creating some profiles so I can carve out this diverter, make it look a little more nice. Like that would be good there. I don't know what size hole I need in the middle there. I should probably just do like a pilot hole of 30 seconds. That. This would probably look nicer if I had these kind of softer corners here, maybe. Oh. Either way, there's that. A sketch. Object. Do this to the back side. And those are still two bodies, fine by me. Let's also let's extrude that to the back side. There's my pivot point. It's all good to go there. Turn off the sketches. Probably do a little bit of fillet on this corner here. That could look pretty nice. Can I? Pretty smart. Actually, before I do that fillet, I'm going to join these bodies. And I'm going to make this a new component. Okay. There's the diverter component. Oh, you can get all kinds of fancy with this. Make it 0.25. Enough. Same thing over here. Nice. Now it's shaping up to be kind of a nice little diverter. One thing I didn't do that I need to do is I've got to build kind of a little bit of an arm onto the back of it. Maybe I can just build it off this side here. Yeah, it needs a little bit of an arm on it so I have a leverage point. So I can pull the diverter down when I need to. All this left diverter. Alright. That's looking a little bit better. That should work out alright there. I need to figure out a lever or arm off the top of this. How that's gonna work. And I need to build a little bracket to mount that to the top of the rail, where that pivot point would be. Just a little L-shaped bracket where I can join it with a little bolt or something. Yeah, I probably shouldn't have rounded that top off there. And I push-pull this. Oh, not there. Definitely not that. Ugh, this guy. What's up, Gorin? How's it going? I'm just designing magical diverters. Like this fancy little piece of metal here. Started off as a paper concept. Not designing a topper, but designing a little sketch on paper on how I want it to work. And then bringing it into here. So I already had the profile etched into the playfield. So I used that to create a sketch and figure out as like two separate pieces. So I had like this top portion here, and then I sketched the bottom portion here, and then I kind of created a pivot point and rotated until like when this is up, the ball will pass underneath it. So I've got sketches it. So there's the ball plus an extra 1/8 of an inch comfort. So that should roll underneath that without hitting anything. And then when the back portion is raised up, it'll also roll under that without hitting anything. So it's a two-way diverter. It just pivots on that axis there, and then when there's a ball in the shooter lane, it pulls that top part down, lifts the back part up, the ball will shoot out and you have a guide rail to get the ball out into the field of play. So yeah, it would shoot out, and then you can skill shot it either into any of these targets here, or your flipper, or you can full plunge it up the inner orbit. There's also a magnet on a linear rail that can grab it anywhere between here and there. So that'll work there. And then when it's in the up position like it's drawn right now, when you shoot the flu network hole back in the back here, and it pops out here, it'll just instantaneously feed down to your left flipper. Pretty ingenious, if I do say so myself. I'm glad I was able to draw that and get that to a point where it actually works and the ball can roll underneath it like I need it to. With clearance. Yeah. And I should be able to bend a piece of metal good enough, hopefully, with that. But what I need to figure out, I need to build kind of a leverage arm on the back there, where I can somehow have that pulled down with a coil underneath. I could put the pull point where it's up right here, but I feel like that would cause maybe some weird stress on that arm. But I could have it here and then just like pull down in this area. Right now those are just going to be two posts. Two posts like there. But yeah. And getting that all sorted out. I don't think I'm going to do a guide right here. Just gonna leave that straight open. You can still hit that shot without needing to ride this guide rail much. It's already pretty far out there on the flipper, so you're not gonna really be pushing the limit out to this little guide rail here too much. And it plays alright, I think, with just posts there. So yeah, that's that guy there. I need to square the top back up on this instead of the rounding that I did. One of these extrudes. Feature, not that one, should be the one before it. Yeah, that guy. So, gonna suppress that feature for now. So there's that. I need probably the lever arm to match the angle that it's rotated at there, and then pull it down flat. Probably also need to just delete this corner here. Okay, let's go to this sketch. At the play field and the rails. I have a straight line across there. I kind of want a rounded back still, but I need an arm piece of metal that sticks up there. I'm not sure how far out I need to go. Oh, what's the travel of a plunger? About an inch, looks like. Inch and a quarter. So I need something that's like an inch and a quarter travel at 22.5-degree angle. Inch, and we'll just do 1 1/8, so make sure it pulls it tight. And this is going to be really long. Not mean to extend. This a constraint. Oh, it's already got that, so I just need it to incident to that line there. No! Alright. Find this angle. 22.5. Yes, it is. Now let's give a coincidental constraint of that line and that. There we go. So that should give me roughly inch and a quarter travel, which is enough for a solenoid to pull down on, maybe? I'll leave it long, and then if I can trim it down, I will. Yeah. Then I think I want an arc that is tangent to like that, please. Tangent arc. And that and wait. Sure, I'm doing something wrong here. I am confused. Whatever. I'm just gonna do that and that and that. It's maybe a little bit better. And what do I want the back of that to look like? Gotta match that angle there. So I need probably what? A 1/4 inch offset. On that. Those. And just a straight line into that, I guess. So that'll give me the ability to fold some metal over. So let's do an offset width of the metal. That. Okay. So I need to extrude that guy there. And I think this guy here. Yeah. Top portion there. I don't really care if it's 2 objects, but whatever. Get to the back side. And then same thing with that. Also out of there. And extrude this. Okay. Starting to shape up a little bit more. And that kind of goes about 1/4 inch there. Alright, so there's leverage arm, at least as a starter. This is supposed to be sheet metal. I'm not entirely sure if this will turn into a flat or not. Guess let's see. somewhere you can convert to a sheet metal component. I don't know. How do they gotta do that? Properties. Real name steel. Oh no. There's a whole sheet metal section here. Convert to sheet metal. Hunt. On as a source. Select a face of a solid body for interference thickness. Do I have to like select all faces and do this? I don't know. It only lets me do one. Sheet metal rules. Stainless steel. Let's see if what it looks like with a flat pattern. It'll let me. Stationary face. Alright, so it doesn't like that bend at the top there. I exit out of flat pattern. Okay. Okay. Let's do this then. That into here. That. And back to sheet metal. Selected edges. Let's try it. Oh, that is magical. Okay. So now I know. And sheet metal components. Neato. So I need that. Forget what the take up is. It's like half of the radius or something. I can measure that actually. Let me finish this. .069. So let's undo the flange. Extrude this up. We'll just do 0.07. Not sure if I need that much. That's pretty close. I only need a total height of 0.07. I'm sitting at like 0.11 sticks. Let's see, how can I do this? Actually, let's just go project. Doesn't like it. There we go. And what did I say that was? 0.069? Oh. We'll call it 0.07. Well, what is the stainless steel thickness? I forget. 18 gauge stainless steel thickness. .047. So it's that and a half, I believe. What should be the take up? So do times 1.5. Oh. Yep. Okay. So 1.5 times the thickness is the take up. And then I should be able to create a flange off that just fine. Nope. I failed again. Doing terrible at mathing. Let's do this for now. First time. So in the Z direction. So why doesn't it show me the XYZ difference? That's what I want. Stainless steel thickness. Let's do times 2. Twice the thickness. Ah, that does it. What did I do? Half inch on that, I think? Let's do 0.25 plus stainless steel thickness times 2. Alright. There we go. So now I have that bend in there. And should be able to update the flat pattern. And let's take a look. There it is. Magic. So that diverter is designed. Man, cool. Sheet metal rules. Control the thickness, bend radius, reliefs, other settings related to sheet metal design. That's what I need to mess with. Is so I need 18 gauge, whatever that ends up being. A factor, thickness 2.5 millimeter. Stainless steel. That's 1.27. Thickness 0.05 inches exactly. What is that? Send, cut, send? I can't even remember what grade of stainless I'm supposed to use. So we'll go 304. There's 18 gauge is 0.048. Strength and durability, oxidation resistant, this countertops cookware. It's 316. Highly corrosion resistant. Able to maintain corrosion resistance across many different environments. Oh, what's the 18 gauge on that? They don't have 18 gauge. Okay. So it looks like it is 304, huh? And what is their K factor? K factor is 0.36. Let's do 0.36 inch. And oh boy. Math. They've got 0.36 inch in here. I don't know what that is in millimeters. Or is it supposed to be? 9 seems awfully high. Oh, so that one there is already... already pretty close. Do I like drag this out? How do I assign it? I could just edit the conversion. We'll just do it this way. Ah, won't let me... Whatever, it's close enough. I'll just change the K factor to what they say it is. Close enough. I think delete that rule. Yeah. Alright, well, we've got something. Neato. I have a diverter. Baby's first diverter. Oh, let's throw a nice good old stainless steel material on that. Stainless. Brushed. Polish. They got bar, they got brushed radial. Let's do cast, knurled. Kinds of cool stuff. Do brushed linear short. Pending product update. Boo. Well, linear long it is. Sweet. So that's the diverter for the left side. And I'll figure out a way to pull it down. I need some sort of a bracket. Probably would be no, not quite a pop bumper bracket. What do I got? Is there a bracket in the slingshot? Nope. Just the kicker. Sadly, no complete slingshot. Modeled thing out there. Don't have anything in any of these other ones. Guess I'll just have to kind of wing that one. But something is going to have to mount right there to pull that down. Right in that area there. I'll figure out the bracket for that stuff later, I guess. Important thing is that the diverter should function correctly. Need to build one for this side over here too, but just one way. Should be doable. I don't know if I want to mess with that today or not. I guess focus on maybe building the bracket for this diverter at least. So let's create a sketch right there. Add the playfield, don't need to see that. Suppose I could probably project those lines. Be 1 inch. Okay. Okay. And let's go. Let's do that. Stainless steel thickness, new body. Let's just do a new component. And convert that to sheet metal. And that guy there. Go an inch up. Yeah. Nope, not quite. Alright, we'll do 3/4. I probably need a washer in between. Oh no. How thick a washer could be. Not what I want. Let's undo that rule there. And let's push that in, I don't know, 1/8 of an inch, 16th. Let's just do a 16th. That should give me room for a washer. And that goes up 3/4 of an inch. Okay. Sketch. Let's do another circle extrusion. Do the back of this. There we go. Got the hole at least. Do some rounding of corners. Really just do like a quarter inch. Those. Okay. there's a little bracket. How I decide to attach that will probably just end up being like a bolt with a washer in between or something. I'll figure that out later, but I at least got the pilot hole in there. I probably want to push in the edge just so this doesn't like rub on the sidewall. Yeah. Why not? And then I'll need some holes for wood screws. Which I think those are like 3/16. Yep. I'm going about this dirty the way I'm doing this, but I'm not a CAD professional. I don't care too much about the history and how all that ties together in a linear timeline. Come on, let me select the other. Okay. Finish sketch. Holes. Also, I want to give 30-second back to that, just for good measure. And I probably need to shift those over 1/64. I don't think that worked. There. There's a little bracket. Edges. So let's call this it. And let's create a flat pattern for it. Go. Alright. That is good to go. Let's see, how long is this guy? 0.44 inches. I kind of need something full rail 2.44 inches over. It needs to go all the way through the rail and the play field. I should start plopping posts in here too. Oh, that's right, I need that hole. Down there. Let's create a sketch on the surface and project a circle. And from that center point, post 8 barrel. And we'll do an 8 flange. Okay, so those are the 2 holes I need to make for that gate. Let's see, how far apart are those? 0.063. So annoying. Yeah. And offset. Offset, negative playfield thickness. And distance post. There's flange diameter. Forget how far in I came with those. Why didn't I set a parameter of depth? It's annoying. To object then. No. What'd I do? Offset. Negative playfield thickness. To object. Okay, there we go. That hole is now accounted for. Sweet tunes. Okay. Diverter designed. That's good. Got that part done. Took a little bit, but we're there. I'm happy with that. And I have sheet metal flats for it, which is even better. Need to do sheet metal flats for all the rest of the rails and stuff. I think that'll come later, once I make sure all the shots are where they're supposed to be. Let's see, I probably should work on the other diverter. Maybe. Oh, do I want to? Maybe that'll be next time. Probably about ready to call it a day. And place an order for dinner. Thai food. But big accomplishment that I wanted to get done today was design the diverter over there. I wanted to make sure that was going to work before I kind of progressed with some of the other ideas that I had. Which is great. Very happy that that works. And I still got work to do on the Hogwarts side of things. I gotta finish drawing it. So that's coming along pretty nice. It's gonna have to hover a little bit higher, but that'll be a pretty cool feature. And then I still gotta draw the sorting hat area. Kind of like the size of that one. I mean, you'd lose a lot of the back here, but most people just recognize this chunk in the center. Don't really need the back of it. A lot of that would get cut out. But I kind of like the angle of that one and the scale of that one a little bit better, but it might be also too tall. Try to cram that in underneath the glass. Which is kind of why I did the scaled version. Scaled it down a little bit. I still gotta finish the main tower. Either way, once I get this actually finished and drawn as a solid, I can scale it however I like. This other one here is just a mesh. So what I've been doing is going through and essentially dissecting the mesh and drawing Hogwarts. So let's see, here's the original mesh. I've been going through and dissecting that, which is why it's taken so long. Turning that into a solid where I can actually carve, you know, lanes through for the ball. Stuff like that. Getting there. But yeah, good progress today. For those of you who hung out and listened to my nonsense or asked questions, thanks for stopping in. Yeah, that'll do it for today. So have yourselves a pleasant evening.